copy link. Let's go. Let's edit. Control V, save. New stream link. Posted there. Alright, so I think we should be good, hopefully. Hopefully. Yes, there we go. Super annoying, seriously. Like, this is the problem. This is the problem, right? When I let's search. No, don't want to search. All right. Yeah. So this is what happens, right? When my internet goes down. Well, it doesn't go down. Essentially, I think what happens is it's kind of like so much information is happening on this tiny piece of crap. Well, it is a piece of crap. It's a piece of crap. Computer can't handle so much information. So eventually what happens, it goes, no, I don't want to stream. I don't want to screen mirror my iPad anymore because the iPad uses Wi-Fi as well too. All right, let's go. Library. Search. Let's do that. Let's turn that. There we go. Right down. Okay. Hopefully we're back. Okie doke. I'll update 7. I'll update 10H as well too. And then I'll have to tidy up that. Edit. Control V. Save. Alrighty. We are back into it. So, if you're here with me now, welcome back. Hopefully it took us a second or two to kind of get this sorted. All right. Now, quick review. This guy here, this bad boy here, we looked at this. We've been looking at this pretty much for for the past kind of week and a bit now, really. This bad boy here. We've got a special name for it. Hopefully you remember. It's kind of one of two names, right? We call this either the vertex or the turning point form. Turning point form. Okay? Turning point form. Because this form, and we call this a quadratic equation because we're dealing with quads. So quads are like squares, right? Quads. This little form here allows us to mainly pick up two aspects. Well, it picks us up a number of different aspects, but allows us to kind of easily calculate two aspects of, oh my goodness, I'm going super laggy. Two aspects of our parabola, right? So the first one, of course, is our axis of symmetry. Axis of symmetry. Now, remember, our axis of symmetry is where our parabola, like I'll show you, actually I'll draw it for you. Our axis of symmetry is like, here's our parabola, right? It is this line here that goes up through the middle here. It's this line here that indicates that the one on the left-hand side is of the same shape and size as the one on the right-hand side. So it's this red line here. So axis of symmetry in this turning point formula here is this guy here. It is H. And the other aspect, of course, is our turning point, T-U-R-I-N-I-N-G, turning point. So that is the set of coordinates which indicate where the axis of symmetry is. It's that bottom dip or that minimum or maximum value. So it is H, K. All right, where H is the x-axis and K is the y-axis, right? we've done this, we've focused on this. Yesterday, we went ahead and we solved a whole bunch of questions that are focused on the turning points for the graphs. So we went ahead and we kind of we converted each of these formulas here into the turning point form, as you can see there in green. I'll zoom in on this. As you can see there in the green, we converted into turning point, and from that we were able to derive or begin to calculate what the actual turning point was. Okay, where in this instance here, the turning point was 0, 0, as indicated by my H and K here, right? There's my H and there's my K, 0, 0, like so. That's all well and good. We went ahead. Hopefully you've gone ahead and practiced that a little bit more. So we're going to use the turning point formula a little bit more today, and this leads us to question 4. Now, if you've got your textbook here, there was 9b that we looked at yesterday. We're looking here at question 4. Oh, my iPad is dying again. Oh no, there it goes. It's come back to life. The internet is a pain in the butt today. I think because Miss Mac is on at the same time. So, nevertheless, we shall persevere. Let's have a look at this. Righto. It says, and most importantly, it says sketch graphs of the following quadratics, labeling 2 things that we're looking at here. Labeling the turning point, okay, our turning point, and our y-intercept. Now, hopefully you remember the y-intercept. Remember, the y-intercept is when x is equal to 0, right? Remember that. We can calculate the y-intercept. That is where my line runs through the y-axis, okay? We calculate that by saying when x is 0. So, the difference about this question here and how I'm going to approach it is going to be very different to how I approached yesterday's one. Yesterday's, as I've highlighted before, what I've gone ahead and done is I've gone ahead and I'll get rid of these. Is I've gone ahead and taken this value here and I've written it like this. Today, I'm not actually going to do this step. Okay, I'm going to assume that we kind of can begin to see and recognize the patterns that exist here. Okay, I'm not going to do it in this form, but I am still going to use this form. So be aware of that. Okay. Let's have a look at this. Sketch the following quadratics, labeling the turning point and the y-intercept. Now, when it says sketch, it means simply that. It means to roughly get an idea about how you're going to draw your parabola. Now, traditionally, right, the way I showed you is we would take a formula like this, and I would say, all right, draw yourself up a table of values like this. All right, 2, 3, 4, that'll do. We'll actually do it, okay? We'll draw up a table of values, -2, -1, blah, 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 and there's a 2, like so. Then what I want you to do is go ahead and solve it. So quickly, let's solve this. -2 squared is 4. 4 times 2 is 8. -1 squared is 1. 1 times 2 is 2. -0 squared is 0. 0 times 2 is 0. 1 squared is 1 times 2 is 2. And of course, well, we should know this anyway because it's the axis of symmetry. From here, right, we would go ahead and we would draw up a nice, beautiful little Cartesian plane like so. I'll give myself a bit of space for this one because I'm dealing with 8s here. Then we would go ahead and plot it, right? Okay, so my first coordinate here is x of -2 and 8. So, well, actually, let's start at 0, 0. I'll start at 0, 0. Then I'll go 1 and 2. And then I'll go 1, 2, 3, 4, 5, 6, 7. Oh, geez, Louise, it's like all the way up the top there like that. I haven't given myself very much space. So, as you can see, I've gone ahead and drawn my parabola. All right, that's all well and good. But that was a pain in the butt. That was a lot of working out, right? A lot of space taken up, a lot of calculations to get a whole bunch of different coordinates. The key here is using our turning point and our y-intercept to kind of roughly draw, or as it says here, sketch our parabola, right? So, as opposed to this, let's get rid of all of this, like so. I'll actually should have kept that Cartesian plane, but that's okay. All right, so let's do this, and let's do this. That's pretty good. Now, out of this, we want two things, right? We want our turning point and we want our y-intercept. So let's get our TP. Now remember our turning point. What is the indication for our turning point? Okay, it is h, the coordinates of hk, right? Coordinates of hk. Our second thing that we want is we want our y-intercept. Y-intercept. Now that is going to be when x is equal to 0, right? When x is equal to 0. From here, we can start to derive two sets of coordinates. Well, our turning point here, I've got nothing added to x, so my first thing is going to be 0, and then I've got nothing added outside of my square. I should have said I've got nothing added or subtracted from my x value or my square, which is 0, which is h, and I've got nothing added on the outside here. Like this is like plus 0 on the outside, so that's my y-axis. All right, beautiful. There's my turning point. Next thing, you might have to write a little bit of this out if you like. Well, actually, I'll do that as well too. Now, in order to calculate my y-intercept, x is going to be equal to 0. So if we think about it, y is going to be 2 times 0 squared, like that, right? So, of course, 0 squared is 0. 0 times 2 is 0. So y is equal to 0. So my y-intercept, of course, is 0 and 0, like so. There we go. That's strange. That is super strange. Both my turning point and my y-intercept is right here. Well, it shouldn't be strange, right? Because literally the moment before, we went ahead and we plotted our parabola and we saw what it was. The tricky part, though, however, in sketching this graph properly, is kind of determining what the dilation is. Remember, dilation, if we go back to here, is this guy here. This guy here is our dilation, right? This guy here determines how skinny or narrow my parabola is, or how wide and open it is, right? Now we went up ahead and we did this. Where is it? There's our dilation, right? As a quick reminder. Our baseline formula, our baseline for dilation, use purple, is y is equal to x squared, and that's indicated by my red over here. Y is equal to x squared. You can see with whole numbers in green here, right? I've got a 3x squared at the front of mine. You can see what happens, right? It actually narrows it down so much more. See that? It dilates it in a more narrow sense there, like so. Whereas if I go a fractional dilation or a fractional a, you can see over here, it actually makes it go wider. It kind of spreads it out a little bit more, like that. So given that we're sketching something here, okay, given that we're sketching down here, like so, all right, we have to kind of make a value judgment. We've got to make like an estimation of kind of what's happening here. What's happening? So if I'm doing a dilation of 2, I would probably suggest and say, well, we saw actually before here, right? So we can kind of go, well, 1 is going to kind of be, when x is 1, it's going to be like here. So I'm going to say it's kind of like that. That's kind of what my parabola is going to look like so. Now we kind of know it looks like that anyway because we put it in a table of values before, but you can kind of get the gist, get an idea. The more you do these, the more you'll begin to understand what's happening in terms of its kind of width and stuff like that. All right, hopefully that made sense. Let's tackle B. All right, I'm going to tackle B because B has something a little bit weird about it. Righto. Y is equal to negative 3x squared. I'll do this guy in, I'll do this one guy down here. Y is equal to negative 3x squared. Now, the first thing that you're going to see and you're going to notice here is that, of course, we've got a weird negative sign at the front. Now, I haven't delved too much into it, but all you need to know is that when you have a negative value like this here, what's going to happen is my parabola, instead of looking like this, is going to look like this. Okay, let me show you. Let me show you. All right, so first thing that we can know. Straight up, let's have a look at our turning point. Our turning point is going to equal 0, 0, and I'll use green for this. Is going to equal 0, 0 because there's nothing subtracted from the square, nor there is there anything added to the outside of the square. Second thing, my y-intercept. Now I can calculate in my head and go through the process I did before, but if x is 0, well then everything here is going to be 0. My y-intercept is going to be equal to 0, like so, 0, 0. The difference here that stands out is, of course, the negative. So this is what happens. I'm going to go over here. I'm going to put my little green dot just there. Hopefully you guys can see that. Okay. This time what's going to happen is, it's given that I've got a dilation here of 3, it's larger than my 2 that I had up here, right? So it's going to be narrower than what I had before. More so, it's also going to go down, right? So I'm going to sketch it something like even this. I'm going to sketch it something like that. Notice how I'm kind of just roughly doing a line, like so. That's how I'm going to sketch it. You can kind of see that the dilation that I've done there is probably slightly more narrow than what's... Let's actually test it. Let's copy that. Copy, paste. Let's move you. Yeah, so there you go. You can see, right? The dilation is definitely much more narrow than my 2 there. It's not perfect, it's not accurate, but that's not what the question is asking us to do. It's not asking us to be accurate. It's simply asking us just to sketch, give us a rough idea of what's happening here, like so. All right. Hopefully that kind of makes sense, and you can kind of begin to understand that. Let's do a different one. I'll do G first. So we'll do G. So the G looks a little bit different. Y is equal to negative x squared plus 1. Y is equal to negative squared plus... Y is equal to negative x squared plus 1. All right, so let's have a look here. First thing I notice, there's a few things I notice. First thing I notice is it's got a negative, so it's going to be a curved down parabola, like so. Second thing that I notice is that I have a value that is added to my square, right? So that looks like a k value in my formula, right? That's the k value over here added. All right, let's go ahead. Find out my TP, my turning point. Well, I don't have a value, I don't have a H value here, so that is 0. I'll actually get a different color. Let's go pink this time. I don't have a value here, 0. But I do have a value that's added here, right? So that there is going to be 1, like so. My y-intercept. Now remember, x is going to equal 0. 0 squared is 0. 0 plus 1 is 1. So look at this. Both my y-intercept is at coordinate 0, 1, as is my turning point. Really weird, right? So, actually, will I add it to this? Yeah, I'll add it to this. But the other thing I notice as well too, of course, I've got a negative there, so it's going to be down. It's kind of like the same as saying negative 1x, right? So, it's going to look something like this. So, it's going to be, my turning point is at 0 and negative 1, which is going to be right here. Wait, is that right? No, sorry. 0 and 1 is up. There it is there. 0 and 1 is there. Okay. And then it's just my regular formula like that. So it just kind of looks like that, right? Just kind of looks like Did I do that right? Yeah, I think I did that right. It's pretty close, right? So as you can see, it's a little bit, it's much more wider than my green value here, my negative 3x squared, of course, because I've got a value of 1 at the front. It is also probably much wider than my 2x squared, as you can see, because again, it's got a value of 1. So the larger the a value, the more narrower it is. Again, not 100% perfect, but pretty close, pretty kind of relatively accurate like that. Hopefully that makes sense for question 4. And you can kind of go ahead and kind of tackle a few of those things on your own. Now, let's have a look at question 5. Question 5. Let's get rid of you. All right, let's do question 5. State the coordinates. This one's an easy one, right? Because it's simply just asking us to literally state the coordinates of the turning point for these graphs, okay? And we should know this by now. Literally, we've been banging on about it for so long, right? Look at, there it is there. The turning points are there. Turning point formula is HK, righto? So let's go ahead and solve a couple of these guys. I'll pick a couple of them out. Let's have a look at A. I'll do this in blue. A, I'll just simply write the answer. Well, the turning point here, there is my H. I'll zoom in on that. There is my H here. I'll do that again. There's my H there. There's my K there. But, question 1, trying to go ahead and trick us already. Remember, our formula, and I'll quickly write it, is y equals A minus H plus K, right? But have a look at this guy here. If we zoom in, have a look. This value here is a plus, right? This is a plus. How the heck can we go from a negative to a plus? What value of 3 must it be that's turned it from a negative to a plus, right? Well, it has to be a negative. Remember, when I have like a 2 minus negative 3 like so, that's the same as saying 2 plus 3, okay? So that's how we've gone from this negative value to a positive value. Pay attention to that. Be careful, right? So my turning points for this guy here is going to be negative 3, 1, like so. Negative 3 there, 1 there. Super easy. Let's roll on to, hopefully that made sense. I will leave, let's have a look at B, right? B. Now, same deal as before, right? We have got a positive value there. So that tells me that my x coordinate here is going to be negative 2, right? Because if I take a negative away, it turns into a positive. But also, this guy here has also thrown us for a loop. Have a look-see. This here is a negative, right? Where our formula here denotes a positive. These damn positive and negative numbers popping up again, right? What value of 4 could possibly turn something positive to a negative, right? Well, of course, if you remember way back to year 7 stuff, right? If I have 2 plus negative 3, it's going to result in 2 minus 3. Like that, right? See that? Positive turns into a negative. So given that, of course, this value here is going to be, I should say, this value here is actually going to be negative 4, like so. Pay careful, close attention to that, right? We can have a look at the form, but these positive and negative numbers will rear their ugly heads quite a lot. C is pretty straightforward. As you can see, we've got our negative value there, which correlates with our turning point formula, and we've got our positive there. So this one is nice and easy. This one here is just 1 and 3, like so. All right. There's the first 3 questions of number 5 done. The rest of it is, of course, up to you. You can see that for pretty much all of question 5, the turning point is there. It's really easy to see, but the tricky part here is disseminating these positive and negatives, right? Pay careful, close attention to that. Pay careful, close attention. All right, let's have a look at Let's have a look out. I'll get rid of you now. I don't need you anymore. Question 6 is the last set. Paste. Let's get rid of you. All right. We want to crop. You go there. You go there. I'll get up. Question 6. It says, all right, more sketching. Sketch the following quadratics, which is just what these formulas are, right? They're just our turning point formulas. That's what quadratics means. Sketch them, labeling the turning point and the y-intercept. All right, I've done enough scaffolding for you guys. It's now really just time just to kind of look at this and go ahead and just roughly sketch it, right? So I'm going to quickly do Cartesian plane like so. Actually, I'll do it over here, more in the middle. Here we go here. There it is there. All right, so let's color coordinate what's happening here. Let's do an orange guy first. So I'm going to have question 1 here be my orange. All right, so let's start with the turning point. Okay, so the turning point is really easy. It is going to be, well, pay careful, close attention. This here is a positive 1, right? So if this is +1, remember that means that the x-axis is going to be negative x, right? So it's going to be -1 + 1. So my turning point is going to be here, like that. See that? There's -1 + 1. There's a 1 across, that's -1. 1 up, +1. Like so. All right. Next part is my y-intercept. Now remember, y-intercept is when x is equal to 0. Let's just do the math on this. 0 + 1 is 0. 0 + 1 is 1. 1 squared is 1. 1 + 1 is 2. So therefore, when x is 0, y is 2. All right, and if we go here, x is 0, y is 2. There it is there. There's my 0, 2 coordinate right there, because we're 0 on the x-axis, 2 on the up. As you can see, it's a regular dilation, nice and easy. We can use this to start, 1, 2, 3, sketching, like so. There we go. Not perfect, but there we go. I've gone ahead and I have sketched my very, very first parabola. I haven't gone ahead and done a whole bunch of calculations and written them out. You can do that if you like, but I've gone ahead and sketched them all up here. Let's do another one. Let's stick to let's go for the second one here. This second guy here is red, so we'll do our red guy here. Now again, I can see here I've got a positive there, right? So it's going to indicate to me that my turning point for the x is going to be -2. I can also see here that this guy here is a negative, where in my formula, I remember this should be a positive. So I can tell that both of these values here are negative values. So my turning point is going to be -2, -1. So if I go here, -2, -1, there it is there. Okay, -2, -1, -2 along my x-axis, -1 down my y-axis. Now, my y-intercept. Remember, y-intercept is when x equals 0. Let's do the math on this. When x is equal to 0, 0 plus 2 is 2. 2 squared is 4. 4 minus 1 can't do maths, is 3, right? So when x is 0, y is 3. When x is 0, y is 1, 2, 3. There it is there, like that. From here, right, I can now sketch my parabola. Like that, right? There it is there. So I want to make sure that my y-intercept is good. So the thing is, when I'm sketching, right, I actually can use my y-intercept. Like if I drew a line here, like that there, I can see that it's like 2 to the side there, like that. So if it's 2 to the side there, I can kind of use that information to go, well, there must be a point here, like that, right? Must be a point there, like that. Oops, undo that. I need a smaller rubber. And so from there, I can then go ahead and go like, all right, cool. Let's go ahead and kind of sketch this guy. There it is there. All right, it's 10:40. I've got year 7 up next, but I'm enjoying this. So I'm going to do one more. Quickly, does anyone have, do you have any specific letter that you want me to do? No? Don't worry about it. I'll choose the very, very last one. Let's do the very last one. We'll make this guy green. Do this guy green. All right. First, there's a couple of things I'm going to notice here, right? I know it's going to be negative. I know it's definitely 100% going to be negative. But my turning point isn't influenced by the dilation here at all. So, firstly, I'm going to calculate my turning point. First thing I'm going to notice is this here is a positive. So that's going to indicate that this guy here is going to be a negative. So it's going to be a -2. And then the second guy here, of course, that's a positive. That fits with my formula. It's going to be 2. So my turning point is going to be -2 on the x-axis and 2 up. So let's go, -2. There it is there. There is our -2 and 2, like so. All right. Second thing, we want the y-intercept. Remember, y-intercept is when x equals 0. 0 plus 2 is 0. Now, given that, it is, we're actually dealing with, I should say, let's start again. 0 plus 2 is 2, right? But pay careful close attention, right? Because it's actually, we're going to be dealing with a negative here. So what we're going to be doing is we're going to be doing a -2 squared, which of course is equal to, can't do the math, sorry. So we do the square first. So how it looks is, I'll do the working out for this. So we've solved this. It actually looks like this, -2 squared, like that, plus 2, right? So we do the squared first, which is going to equal 4, right? But remember, there's like a 1 at the front here. So this is like -1 times 4. So my answer just becomes down here, -4 plus 2. -4 plus 2, of course, is equal to -2, like so. So when x is 0, y is -2. Let's do that. X is 0, y is -2, like so. 0, -2. And that makes sense, right? Because I've said all along, whenever you see a negative at the front, it's going to be like a downward, it's like going to be a downward facing parabola, like so. So we can go ahead and we can kind of sketch our parabola like that. And again, we can use the same property as we did before to determine its parallel. So there, we've got to 2, because that's our axis of symmetry there, like that. So I know that it's going to be 2 over to the side, like so. From there, I can just kind of sketch my parabola like that. Again, not 100% perfect, but there it is there. That's how we go ahead and we sketch our parabolas. Whew. I know I talked fast, but hopefully that was thorough enough and you kind of got a lot out of that. Practice this, take your time with this. Go ahead, sketch these. Enjoy them for what they are. All right? Okay. Any questions? No questions? Let's go into my emails. Go over all the time. Awesome. Thank you to those that popped by and said hello and stuck with me past through the technical issues at the start. All right. We will. Nothing there. Nothing there. Okay. Alrighty. Thank you to those that were here. I appreciate that. Hopefully you learned something. I'm going to redo this with year 7 now. Alright, have fun. And